Good morning friends. I hope everyone is doing well. In this video, I want to discuss one of the gate question which came in the year 2017 related to the pipeline. First let me read out the question, then we will solve it. A 5-stage pipeline consists of 5 stages as instruction fetch, instruction decode, operand fetch, execute and write back. I have written in shortcuts as IF, ID, OF, EX and WB. These stages takes 5, 4, 20, 10 and 3 nanoseconds respectively. So each stage is taking different delay. Each register takes 2 nanoseconds delay. Two pipeline implementation of the processor are contemplated. So they have implemented the same one using two pipelines architecture. What is the first one? It is saying a naive pipeline implementation with 5 stages. This is the same thing. Now what they have done is that they have implemented another one, the efficient pipeline, where OF is stage 3 is divided into two stages as OF1 and OF2 has 12 nanoseconds and 8 nanoseconds. So if you divide this one into two stages, OF1 and OF2, totally how many stages you will have? 2 plus 2 plus 2. So totally you will have 6 stage pipeline. Now they are asking us to calculate the speed up achieved by efficient pipeline EP over naive pipeline NP for executing 20 instructions. And they have given the 4 options. We need to find which is the right option. So first we will calculate if we execute these 20 instructions using naive pipeline with 5 stages. Okay. So using the pipeline, if I want to calculate the time, it will be k plus n minus 1 into Tp. To execute n instructions, we need to take the time as k plus n minus 1 into Tp, where k is the number of stages in the pipeline, n is the number of instructions we are executing. So how I got this formula is, if you have n instructions, out of this n instruction, 1 will take k cycles and remaining n minus 1 instructions will take 1 cycle each. So totally you will have n minus 1 plus k cycles. If we consider that each cycle is taking a delay as Tp, then we will get the total delay as k plus n minus 1 into Tp. In this question, what is the k value? Is 5. And how many instructions we want to execute? 20 instructions. 20 minus 1 is 19. Okay, into Tp. We need to calculate what is the Tp. Meaning is that cycle time or clock time we need to calculate. If you see that each stage is taking different delay. If each stage is taking the different delay, we need to find the max among them. Is it clear? What is the max between 5, 4, 20, 10 and 3? 20 is the maximum. Am I right? For the delay, we need to add the register delay, because between the stages, if you see that between the stages, we will have a registers. What is the purpose of this register? The output of the stage 1 will be stored and it will be considered as an input for the stage 2. So we will have a registers in the between the two stages in the pipeline architecture. So they given the register delay as 2 nanoseconds. So you need to add 2 for this 20. So you will get 22 nanoseconds is the cycle time. So 24 into 22. If you multiply, you will get 528 nanoseconds. So if you implement 20 instructions using naive pipeline with 5 stages, we got 528 nanoseconds. So we will write it in here. So using naive pipeline, I got 528 nanoseconds. Now what I have to do? I have to execute these 20 instructions using the efficient pipeline. Same one, k plus n minus 1 into Tp. What is the k value here? It is a 6-stage pipeline. So 6 plus n is 20 minus 1 into Tp. What is the Tp here? if you see that we have 6 stages. So stage 1 is taking delay as 5. Stage 2 is taking the delay of 4 nanoseconds. Now stage 3, they have divided into 2, consists of 12 nanoseconds and 8 nanoseconds. So 12 comma 8. Are you able to understand? Previously OF is taking 20 nanoseconds, but this OF they have divided into 2 stages called OF1 and OF2. OF1 is taking 12 nanoseconds, OF2 is taking 8 nanoseconds. So we should not consider 20, we should consider it as 12 comma 8 and 10 comma 3. So max between 5, 4, 12, 8, 10, 3 is 12. So we got the maximum delay as 12 nanoseconds. For that one, if I add the register delay as 2 nanoseconds, I will get the cycle delay as 14 nanoseconds. So what I have to do? 6 plus 20 minus 1 is 25. So 25 into 14, you will get 350 nanoseconds. Are you able to understand? So if I execute these 20 instructions using efficient pipeline, I got 350 nanoseconds. The same instructions if I execute using the Navy pipeline, I got 528 nanoseconds. So now what they are asking? The speed up achieved by efficient pipeline over NP pipeline, meaning is that Navy pipeline. So you have to divide the efficient pipeline by NP pipeline, Navy pipeline, which is equal to 528 nanoseconds by 350 nanoseconds. You will get approximately 1.51. Okay, you can check it. Okay, so the right answer for this question is 1.51, which is option A. Are you able to understand? Okay, I hope you have understood how I solve this question. If you still have any doubts related to this question, feel free to ask me in the comment section. If you really like my teaching, please press the like button, share the videos with your friends and subscribe to my channel. If you don't like my videos, share the videos with your enemies. So the objective is that don't stop sharing the videos. Share either with your friends or with your enemies. I hope you are enjoying the videos. Please press the like button. Okay? Thank you for watching my videos. Have a nice day.